Elasticity. This is the first of at least 2 recordings. Elasticity. Previously, when we talked about supply or demand, and here I'm going to use demand as an example, we just drew a demand curve, right? We got a quantity here, we got a price here, we got demand, and we just drew a demand curve. So what we're going to do now is talk about situations where the demand curve has a different shape. For example, there are some things that tend to be a situation where when the price changes, let's say that this is price 1 and then price 2 occurs. So the price goes up. At price 1, here's the quantity. Whoops. There we go. Here's the, here's the quantity. That's just terrible. But, oh well, you get the idea. And at price 2, here's the quantity. Okay, so here's quantity 2, and here's quantity 1. Notice that the change, that's supposed to be one of these, here, is smaller than over here. So the change between these 2 points is or the range is smaller, relatively speaking. And when we get to talking about relatively speaking in economics, we're really talking about the percentage change. As a percent of the values involved, it appears from my rough drawing, very rough, that quantity has changed less as a response to a price change. And remember, I told you, in economics, just because of history, our prices are independent value. So we're saying the price happens and then the quantity responds as a dependent variable. So the price is independent. So we got them on the opposite axes of a normal math situation. So price changes, quantity responds, and look, the quantity is responding less here. So this would be an example of something that we have to have, like insulin. I mean, if you're diabetic and you need insulin and the price goes up, you're probably going to use close to the same amount as before. Some people won't be able to afford the change and they may have to purchase less, but you don't do it willingly. And things we're addicted to. Booze, cigarettes, heart medicine, blood pressure medicine. The price changes and the quantity doesn't fall as steeply. And there's also a situation where a demand curve can be very flat, and that's the opposite situation. In that case, I can't even hardly draw it. The price might change just a little bit. And let's say we're going up a little bit, the quantity is going to change a large amount. And this isn't just slope. Elasticity is something different from slope. So don't say, oh, well, it's just the rate of change at that point. That's part of it, but elasticity is a little bit more. So what we find is that on a straight line, for example, even if it was absolutely straight, the elasticity at 2 different points would be different because it's not slope. Whereas if it was an absolutely straight line and we looked at different points, the slope should be the same, right? The rate of change. But it does change, elasticity does change from point to point or arc to arc on even a straight demand curve. And that last little paragraph about the difference between slope and elasticity, that's mostly for the people that are, mathematically astute, and they're thinking, oh, it's the slope. No, it's not the slope. And so what we're really looking at, we're saying the elasticity, and we'll start with the elasticity of demand, although there are 4 types of elasticities. Elasticity of supply, elasticity of, we call it income elasticity instead of elasticity of income. But income elasticity and cross elasticity. We're going to learn about all those, although I basically just mention supply elasticity and tell you it's going to be measured the same way as when we measure it on a demand curve. I usually don't, require people to actually do the computations on supply elasticity. So there's 4 types. We're going to look at demand elasticity because that's the most common. And let's go with what we were talking about here. If we're looking at the over an arc or a change, 2 different prices and 2 different quantities, we're really looking at the percentage change in the quantity given a percentage change in the price. And so what we need to do is go to a new page and figure out what that means. Okay? So let's go to a new page and let's see if I can make this with graph squares. Okay. Okay, so I told you that demand elasticity is equal to the percentage change. I am not having as much skill at using my hand as I have in previous lectures, so bear with me. That's the percentage change in quantity divided by the percentage change in price. And what I'm going to do is take each one of these. So the numerator I'm going to give you here, and the denominator I'm going to give you here. Okay? So basically a percentage change in quantity means we're going to take 2 points, and I'll explain what those are in a minute. For now we'll call it quantity B and subtract quantity A. And then we're going to find the midpoint, or the average of those 2 quantities. Okay? And we're going to do the same thing with the prices. Price B minus price A divided by the average of the prices. Okay? So I'm going to... Hey, I can't believe I drew a really straight line. That is pretty awesome. Wow. Okay, price, quantity, and I'm just going to put a demand curve in here, just an arbitrary demand curve. And let's see, I'll put in some points here. Let's see, and I'm going to label them. I really can't. I'm just going to put the numbers on the inside instead of the outside of the graph so that you can see what they are. And okay, we're going to call that 5. And 10. And 15. And 20. I can see something on my graph that's in the way. It probably won't show up on yours, but there's something there giving me options to do things, and I cannot draw below there. And down here, 25, and if I continue that on out, 30. Okay? So there's our graph. And what I'm going to say is that there's two ways to find elasticity. When you get to intermediate micro, which I'm teaching this summer, by the way, for those of you that are fairly decent at math, that aren't afraid of math, we don't do much. We do derivatives. So for those of you that know what derivatives are, and if you don't know what derivatives are, they're an easy way to simplify math. Sometimes, in order to avoid using different mathematical techniques at the introductory level, for example, we will just use algebra, and dividing and subtracting and fractions, just basic stuff. And sometimes that's harder than if you just use derivatives. Derivatives, you can find elasticity at a certain point. But if you're not going to use derivatives, and those of you that don't know what derivatives are, don't worry about it, we're not going to use them. But for those of you that do, in intermediate micro, we learn to do easier techniques, in economics using derivatives. So we find instantaneous rates of change instead of finding it over an arc. But in this class, we're finding arc. And so what we're going to do is for each arc that we want to choose, we are going to label a point. So I'll just label this one A and this one B for now. And what we're going to do is we're going to find the elasticity on each one of these, okay? And I'm going to have to do some erasing and things in order to get this all to work. But what we're going to do is, or you know what I can do? I can write, there's just not a lot of space here. I can write in another color above and around these formulas. Okay? So we can find the quantity, and you've got it in your notes. If you don't, back it up, put it in your notes, okay? Because we need to find some space to work here. So what I'm going to do is I'm going to show you to find quantity B, which is this one. Oops. Quantity B. We're going to go to point B, and that number is 10 down here on the quantity axis, right? So we're going to put 10 in our formula. And then quantity A, we're going to start at this point, we're going to go to quantity axis that matches up with point A because we're finding the elasticity for that arc. Okay? So quantity A was what, 5? So 10 minus 5 will be in the numerator of this fraction, and the average of those is also the midpoint. So you can look at it and say halfway between 10 and 5 is what, 7.5? Or you can add the 2, 10 plus 5, and divide by 2, because there's 2 we're looking at, the endpoints, right? 10 plus 5 divided by 2 would be 7.5. So however you do that, this fraction is going to end up being what? 5 over 7.5. I am filming this late at night, and I'm probably going to reuse this in future semesters, but this particular semester I have been extraordinarily sick. And so when I feel good, I am trying to get my work done. So, I'm picking up my, here it is, calculator. It is like 2 in the morning. No, it's not. It's 1:30. So, hope you catch me if I make little absent-minded math errors, but 10 minus 5 is 5. The average is 7.5. That one looks right. But work them out yourself and make sure that, you know, that I'm not just making an absent-minded error. That plus my age, and it's highly likely. Here we go. Now, we're going to do the same thing with the prices. So the price, we're going to be on this axis. So price B is going to be 5. So 5 minus price A, which is 6. And then the average, or the midpoint, you can either take 5 plus 6 equals 11 and divide by 2. And what are you going to get? You're going to get 5.5, which also you could just look halfway between 5 and 6 is 5.5. However you do this, you're going to end up with minus 1 over 5.5. Now, the mistake that you could make here is to find the decimal answer to each one and divide them, because you're going to have to take basically this one and divide and put it in here and this one and put it in here. So you're going to be dividing this fraction by this fraction, right? Well, how do you do that? How do you divide a fraction by a fraction? Remember, invert and multiply. If you're going to take, if what you're getting is, and I'm going to do some erasing just to make room, okay? If what you're doing is 5 over 7.5 divided by minus 1 over 5.5, you're going to invert and multiply, right? So how do you do that? Well, invert and multiply. I've got to find room. That's what I'm sitting there wondering how to do. Find room on this. I'm going to do it down on the bottom right-hand side. I'm going to take 5. I'm say all of that is equal to 5 divided by 7.5 times, I'm going to take the percentage change in price fraction, and I'm going to find the reciprocal, and 5.5 over minus 1. So that's going to equal 5. I wrote 0.5. Oh, this is my multiplication, and there is a decimal there. Okay. So you're going to take 5, hang on, work the calculator here. 5 times 5.5 equals 27.5. Divided by minus 7.5. Okay? So the value you're going to get here right here is going to be the arc between A and B, and that is going to be 27.5 divided by 7.5, and it's going to be negative, right? So it's going to be a negative fraction. And at this point, you just need to be able to calculate them. So let's arbitrarily, let's just pick another one and do another one, okay? And I really want to just clean this all up. And so you've got your notes. And let's do another one. I'm going to pick down here on the bottom here. I'm going to pick this one. Okay? So we're going to find that one. We're going to do it the same way, and I'm going to label, just to show you it doesn't matter which way you do it. The key is to make sure that you get the numbers that match the B or match the A, and you're consistent in your fraction. All that happens if you switch the B and the A around from top to bottom, like I've done here, on this one I'll make this one B and the other one A, is that the negative sign will be in the numerator instead of the denominator. Okay? So, you've got a negative sign. Basically, elasticities of demand are going to always be negative. Can you... I hope you could still hear me. Basically, elasticities of demand are going to always be negative because of the fact that the relationship between price and quantity demanded is inverse. Remember that? So your elasticity is going to be negative. So our values are going to be negative. So let's do this arc down here between prices of 1 and 2 and quantities of 25 and 30. And you're going to get a different elasticity, even though, well, it's a fairly straight line. Okay? So it's not the same as slope. Okay, so we're going to have to find the percentage change in the quantity, and then we'll find the percentage change in the price, and then we will divide them. Okay, so percentage change in quantity, let's see, that's going to equal quantity B, which is 25, right? Minus quantity A, and remember I'm going down here on the quantity axis, 25 and 30. Divided by what? Midway between those is going to be what? 27.5. Or again, you could find the average, which is really the formula, the average, which would be 25 plus 30 divided by 2, which will be 27.5. Okay, and the percentage change in price, we're going to be over here on the price axis. So B minus A is 2 minus 1, right? So 2 minus 1 divided by the average, or the midpoint, is what? 1.5. And again, you could have taken 2 plus 1 and divided by 2, so it would have been 3 divided by 2 equals 1.5 to get that. Okay? So, this one, I'm going to change. 25 minus 30 is minus 5. 25 minus 30. Okay? And this one, 2 minus 1 is 1. Okay? I'm just erasing. I hope you had that written down, but I'm just trying to save space here. So then we're going to invert and multiply, right? Because we want to divide, right? So what we're going to do is we're going to take minus 5 over 27.5 times the reciprocal of the percentage change in price, 1.5 over 1 equals. Now, I told you, don't use your calculator and find the decimal value of each one and then divide them. Because you could. I mean, I suppose you could find the decimal value of this one and then divide it by the decimal value of that one. However, you will lose decimal points and you'll be less accurate than if you wait until you find this final value here and then find the decimal value. So the key is to be accurate. So let's do it this way. Keep this one as a fraction, find the reciprocal of the other one, and multiply the fractions. And how do you multiply the fractions? We're going to multiply them across, right? So the minus 5 times 1.5, I think in my head that's going to be minus 7.5, but I'm going to turn on my calculator and do, because it's late, like I said, and I'm old. 5 times 1.5, 7.5, and it's negative, so minus 7.5 over 27.5, because we're going to multiply across this way. There's a point there, and it's like, ugh, my finger isn't working as well. Okay, so that's what this value is going to be. So let me erase a lot of this garbage. Hope you had it in your notes. Remember, you can go back and you can see what we did. Okay, so that could be a good homework assignment. I'm thinking here, I want to use this in future semesters, but in the current semester I have one class that's behind the other class. So for the class that was assigned to read this, this will be a required assignment, okay? Homework assignment, and you will email me the values for the rest of these. Okay? And I just erased this thing. And so it was what? Minus 7.5 over 27.5? Was that it? Email me this one too. I didn't mean to erase the last one. But anyway, email me values for the rest of these arcs and for the complete thing. Okay? So you have a homework assignment. And you probably want to get this done soon because there's a sapling assignment as well. So you want to be able to do those. So go ahead and work these and email me these before we meet again in class. Okay? Besides that, we're going to keep going. So, what does all this mean? I'm going to go to a new page and show you something. By the way, this one was, I believe, now I've erased it, but I believe this was minus 7.5 over, what did we say, 27.5? I believe that's what that was. Just going looking at my calculator, 5 times 1.5 and 5 times 5.5. Okay? So, notice that this one is less than 1, and this one is greater than 1, and somewhere in here, we don't know where, this is going to change, and somewhere it will be equal to 1. Okay? Now, that matters, and on the next page I'll show you why. When we were talking about the percentage change in the quantity and the percentage change in the price, and I showed you, well, some things, when the price changes, say, by 10%, the change in quantity changes by 1%, for example. And when that happens, if, say, this number was 10% and this number was 1%, then the fraction itself, oops, I drew it opposite of what my brain was saying to draw. That's really scary. In that case, that's going to be a number less than 1, right? Then that would be something like insulin or something, where the price goes up and the quantity just doesn't change by the same proportion as the price. And in some cases, it could be greater than 1, and that would be, well, things like cars. Cars have a lot of the range of their elasticities in the price where we normally buy it are very elastic. And so that would be something where this elasticity of demand, in that case, would be something like, ooh, I should draw it like this. Something like, say, 2% for every 1%. So the change in quantity is always the numerator. So that would be the price changes by 1%, and that is a percentage sign. And the change in the quantity is double. So that would be something we call elastic or greater than 1. So let me draw you a little chart. Another page. Here we go. From 0 to 1 to infinity and beyond. So we're going to have this range and basically, by the way, 1, if the elasticity is 1, economists, we just can't be, college professors, and I'm guilty of this myself. When I write a paper, I don't want to sound just ordinary smart. I want to sound really intelligent when I write a paper. And so when I publish a paper, if I get a value of 1, and we all do this, we go, the answer is unitary. Snobby. But we're trying to sound really smart. So we call this unit elastic, which basically means 1. Okay? And if we have a value of 0, we're going to say perfectly, because it's at the absolute end, right? You can't get any better. Perfectly inelastic. And if we get a value of infinity, we're going to say perfectly, and I'm running out of space there, elastic. And by the term elastic, we mean how much of a response, how much does the other one, does it stretch? How much does quantity stretch when price changes? So anything greater than 1, remember over here, if the quantity, remember this one, the numerator here is basically the percentage change in the quantity. That is supposed to be an arrow from quantity. And down here, price. I know, just my hand's not working real good at the moment. So that's the best I can draw, and too bad. Price is in the denominator, so when price changes 1%, quantity changes by a number larger than 1%, you get a value, the fraction is greater than 1. So, going back to this page, that means that anytime our value of our elasticity is greater than 1, we're going to say it's elastic. Okay? And if it's less than 1, we're going to say it's inelastic. In other words, quantity just is not stretching or moving, and I'm using a term stretching because we all know what elastic is, right? And we all, when we were kids, we had clothes with elastic bands around the waist instead of, it had elastic in there instead of belts and things. Belts and zippers, we didn't do that as much as we had a little elastic band to hold them up. So we know what elastic is. So if we're in this situation, now we're up here. In this case, there was a 10% change and a 1% change. So price changed by 10%, but quantity changed by only 1%. In that case, anytime you have a fraction where the number, let's look at some fractions here. 3 over 5, 1 over 10, 12 over 30. Each one of these is less than 1, right? When the numerator is a smaller number than the denominator, you have a value of less than 1. And vice versa for the situation down here, right? Where in that case, the numerator is greater than the denominator. Okay, so back to where we were. So inelastic if the fraction is less than 1, and elastic if it's greater than 1. Okay, so taking this back to this screen, this is less than 1, so it is inelastic. Did any of you notice I dropped off the minus sign? And you're thinking it's because I'm old and tired. No, actually, we dropped the minus sign. We use the absolute value when we're calculating this. So we find the value. It is negative. All of these are going to be negatives. All of these are going to be negatives, negatives, negatives. But when we go to the chart, we're going to use oh, hang on, go away. I got a problem here. This thing has dropped. Something has dropped down, and I don't want it to drop down. I want this to go away. There, okay. I just slide it. I was trying to tap things. Okay. So you couldn't see it, I bet, because it was controls. But I ended up writing on it, and it dragged it down. Use absolute. Oh, I did it again. I want to put a B there, and it's trying to drag this down. So I'm going to write the B a little lower. Nope. I got to write lower. Dang it, did it again. Bear with me, y'all. Absolute value. I hate that when you're trying to write on it, but there's this drop down thing, and if you get your finger within you know, one of these squares of this thing, it drags down this menu. Okay, so we're going to use the absolute value for this chart. Okay, so no, I was not forgetting. I was maybe forgetting to tell you ahead of time, but we did this correctly. So if we had a value of a fraction that was between 0 and 1, which, go back here. For example, down here, this is inelastic. And up here, it's greater than 1. Oh, I didn't say that earlier. And you guys are going, no, negative is not greater than 1. Okay. Bear with me. Is it making sense now? So we're getting a negative. We're going to ignore the negative. And it's negative simply because of the fact that the demand curve has an inverse relationship between price and quantity. Remember that law of demand? Okay, and since it's only a result of the fact that it's a negative slope, then let's just get rid of that, look at the absolute value, and see that fraction is greater than 1. okay? Otherwise, true, a negative fraction would be less than 1. I get that. But the reason we do that is there's a reason. Let's go forward. The reason is when we use or find elasticity of supply, we can use the same chart. And I don't know if I have room to write chart. Okay? So if we were to use and try and find elasticity of supply, it's the same thing, percentage change in quantity divided by percentage change in price, except we would be doing it this way. You'd have a supply curve here, quantity, and here we go. Isn't this beautiful? Supply curve, quantity, and we would do the same thing with 2 points over an arc, right? And we would say, okay, here's point B, here's point A, here's our quantity, here's the other quantity, etc. We would do the same kind of calculations, except when we got done, we would get a positive sign because there's a positive slope. So what we can do now is, if we use the absolute value on the demand elasticity, then the chart we use for that one can be used for the elasticity of supply as well, because it will be absolute value just naturally. It will be positive. So, boy, that's messy, but you can do the exact same kind of calculations the same way on a supply curve as you do with the demand curve. This is a long, long video, but that's enough for this one. And I do hope, with the late hour and my being not at my best health and other reasons, I do hope you got something out of this. I will know when I get your homework coming in the email whether you got this. Good luck, and I will be in a few days doing another video for both sections, and we'll be talking to you soon.